Welcome to qnawire.
Okay, so for part A of this question, we're looking to find what the progeny will be from a vestigial winged hairy male and a homozygous normal female. So you see we have our vestigial winged hairless male. Those are both the recessive phenotypes, so little l, big little h, crossed with the homozygous normal female. So big L, big H, big H. So if you think about what the Punnett square would look like for this, each offspring is going to get one big L and one little l because the mother and father are only able to give big L's and little L's. So there's no way to get a mix of big L, or little l, just one big L and one little l. And same thing with the H's. So we know that the genotype of all of our F1 progeny will be big L, big H, little h. Then when we're trying to think about what their phenotype will be, because the big L and the big H are the dominant phenotypes, just because the offspring have at least one of that allele, we know that they will have the dominant phenotype as well. So big L is long wings, so that's why they'll be long-winged, and big H is hairless, so that's why they'll be hairless. Then, part B gets a little more complicated. It says, if the F1 from this cross are permitted to mate among themselves, what would be the progeny expected in the F2 generation? So the F1 are big L, big H, little h, as we discussed above, heterozygous, dominant. And so if we think about what the alleles that they're able to give their offspring will be. So there's a big L and a little l. So we know from doing the Punnett square out, I'll do one example one on the side. Big L, little l, big L, little l. So we know that there's a 1/4 chance of getting big L, and then there's a 2/4 chance of getting big L, little l, because both of these are big L, little l, and then there's a 1/4 chance of getting little l. So that's where these numbers here come from. Then you do the exact same Punnett square with the H's, and you get 1/4, 2/4, 1/4. Then the next step is just multiplying across all those numbers. So if you have 1/4 big L, 1/4 big H, you multiply across, you get 1/16 big L, big H. Same with the next one. 1/4 times 2/4, you get 2/16 big L, big H, little h. Same with the next one. 1/4, 1/16 big L, little h. Then you move on to the next row, starting with the big L, little l. 2/4 times 1/4. That's where you get 1/16 big L, big H. Same with the next one, 2 times 2, 4/16 big L, big H, little h. You go through each of these, multiplying across all the possible combinations, and then that's where these numbers here come from. Then, when you're thinking about what the phenotypes will be, so these are the genotypes because they're the alleles, thinking about what the phenotypes will be, you really only care about whether the offspring have at least one big L or at least one big H. So looking at all of the ones that are highlighted in red, big L, big L, little l, big L, little l. All of those have a big L, and then big H, little h, big H, big H, little h. All of those have a big H. So because these offspring have a big L and a big H, we know that they will be long-winged and hairless. So we add up all of those numbers, 1/16, 2/16, 2/16, 4/16, in order to get that 9/16 number. Then we do the same thing for big L's and little H's. So the two highlighted in blue have a big L and a little h. So because they have a big L, we know they'll be long-winged. Because they have a little h, we know that they'll be hairy. Then we do the same thing for the ones in green. These ones all have big H's and little L's. So big H's, they'll be hairless. Little L's, they'll be vestigial winged. And then there's one left that has the recessive homozygous genotype, little l, little h. So that means he'll get both recessive traits and be vestigial winged and hairy. Okay, for part C, so now suppose a hairy female with normal wings, so hairy female, little h with normal wings, big L, little l, since we're told it's heterozygous, is crossed with a vestigial winged normal body male. So vestigial winged, we know it's little l, and then normal body but heterozygous, big H, little h. So we do the same Punnett square trick that we did above in order to get from little h, big H, little h, you know that 1/2 will get big H, little h, and 1/2 will get little h. And then from big L, little l, same thing, 1/2 will get big L, 1/2 will get little l. If you're confused about where those numbers are coming from, I recommend drawing out the Punnett square. So now we're going to cross multiply the same way we did before. We know that we have 1/2 big H, little h, 1/2 little l, gives us 1/4 big H, big L, and then 1/2 times 1/2, 1/4 big H, little l, and then 1/2 times 1/2, 1/4, little h, big L, little l, and then 1/4 of both homozygous recessive phenotypes. And so that's where we get the phenotypes from. The top row has a big H and a big L, so we know that it must be long and hairless because those are the dominant phenotypes. Then the next row has a big H but a little l, so it must be hairless but short. The next one is little h, big L, little l. So because it has a big L, we know it must have long body, but the little h's, it must be hairy. And then the 1/4 little h, little l must have the doubly homozygous recessive phenotype of short and hairy. So that's how you solve that problem.